So this is a test program. Well, a test program. It's more probably a configuration tool to try to test steering. Um, it is out in GIST, and I think I talked about this last time we were together. Made a few changes. For example, like I set the left limit at the actual left limit, but then I subtract a safety margin just to try to make sure things aren't going too crazy. That's one minor tweak to that. And I'm just looking at this, see if there's anything worth mentioning.
Hold,
Trying,
hold, hold on right there for a second. See, at line 100, you say check a time value and then call check safety, which down below it says check safety is just a placeholder. You haven't done anything. Well, you didn't reload your timer right there, which means this check safety is going to happen every 65 and a half seconds as opposed to what you want it to do. And since you're not using it anyway, you haven't noticed that yet. So see it right there. You just got a placeholder of nothing in it. But the point is that timer up there needs an extra line of code stuck in it.
yeah, I thought I put it down here. Okay, thank you for catching that. Yeah, that might explain something. It's taking up.
The other three there seem to be okay, but that one you'd missed that line, and you missed it because you're not actually using it, so it wasn't obvious.
Yeah, and the reason I'm pausing for a minute is one of the other changes I made since we last spoke was to um, try to use the ledc function to set the PWM frequency to try to get some noise out of the motor. And that was actually successful for a little while, but then it didn't work. And I bet, well, I'm hypothesizing that um, the reason it did work and stopped working is maybe because that function is running so fast and it's screwing up the timer. But I mean, anyway, um, so another change that I made was to try to use this ledc function down in the steer vehicle code, the lowest level code where I'm actually sending uh, this is the actual sending to the motor controller a value between 0 and 255. I was testing this statement, which was this was the legacy statement, and I went back to the legacy statement because even though it makes more noise, this was being erratic for some reason, undefined. But anyway, so that's one of the things that's happened in the last week or so is testing this ledc write versus an analog write to the motor controller. So where I'm at the moment is using the analog write, which again produces a lot of noise with the motor. Um, that's the only thing that's going on there. And then you were in the last conversation that we had. Um, my interpretation of your comments was that to quote unquote convert to angle or start dealing with angle instead of this raw potentiometer setting. I took the actual potentiometer, and mapped it to the left and right limit. Um, and I just, again, based on the conversation the last time, used 45 degrees left and 45 degrees right as a starting point for um, that mapping function. In your posts, you seem to suggest, I was unclear what you were suggesting. Should I not try to use the angle that 45 and minus 45 and positive 45 in the code?
Well,
That's a question.
did you read my comments that I posted last night?
I did. Um, I mean,
So there, I trying to point out that what I was suggesting last time is only convert your target pot into an angle. And the reason I suggested that was then at any point you can say, instead of calling get the target pot angle, take the angle that Ross just sent you and substitute it directly. I hadn't expected it to replace everything with an angle, but as I said in my comments, I guess there's no reason why you can't do that. So you can do it one way or the other. You can make everything as an angle and feed that into your PID and it will work. Or you can feed everything as A to D counts from both pots and feed that in, it'll work. Or you can read the target A to D and convert it to an angle, and then basically then convert that angle back into whatever your whatever the other pot's reading. And that would, any one of those should work. So part of it's just a matter of preference, what you want to do there. And it didn't occur to me until I saw you converted everything to angle that, yeah, I guess that would work. You could just read your target pot and convert that to an angle, read your steering pot and convert that to an angle, and just do everything as angles into your PID. And yes, that would actually work. It should actually work.
well, and again, this is a configuration tool program. It's not going to be used necessarily in production. This, um, I mean, certainly getting the steering actual position would be in production, but comparing that to, um, the set point is going to come from, ideally, obviously, the ROS navigation stack, right?
I'm not sure what you're calling set point there. The set point from the target angle or the set point from the steering pot?
Well, in the traditional, most of the PIDs that I see, you have an input and you have a set point. The set point is the target angle, the input is actual angle in my configuration here.
Okay.
So as you've done it before, um, was the set point coming from the ROS navigation stack?
It could come from either place.
And if it comes from the ROS navigation stack, is it? I think we've been through this a few times, so I don't mean to be torturously redundant, but is the ROS navigation stack going to say, I want you to steer to this angle?
It's going to provide an angle, and as I've mentioned multiple times, I don't know if that they say it puts out an angle, but I don't know if that's the angle of your front wheels or that's the angle we want the vehicle to turn as it drives forward. And I can't find anywhere to tell me which is actually correct on that. But the answer is yes. Ross, the way you got your TEB planner set up, where you said set the flag to give me an angle instead of rotational velocity, yes, it will just hand you an angle and then you deal with that. And
Okay.
technically that angle is in radians, but I convert mine to degrees just because I don't think in radians. But regardless, it's an angle. It's just a scale factor between those two.
Cool.
So that's why I was saying if you convert your target pot into an angle, then you can use the angle directly. Or if Ross hands you something as an angle, you can use that directly. Either way would work on that. And it's really just a matter of, as you say, you're just testing right now, but then you're going to say, oh, now I got to get this stuff from Ross. And you're going to figure out, well, how do I convert the Ross angle into something? So it's just, It was just, I thought you could just bypass that step and put it in now, but if it just confuses you, you don't have to do, any of that stuff. It's just at that point where it says error equals set point minus input, both set point and input have to be in the same units. Either have to both be an angle or they both have to be your A to D counts
And
in order to make that work.
right. And so I think the advice is wise to, as quickly as possible, start to use what's going to be used ultimately. And since, well, I'm hoping the feed from the navigation stack is going to be something like an angle. Maybe it'll be in radians and have to be converted, and then I'll already be there with the input. So that's what I'm thinking in the back of my head. So the where I ended up with this particular uh, setup, this is just this potentiometer was being, again, from a testing purpose, just used to change the target angle. This was KI or KPI and D. And I ultimately got to a point where the steering was um, these three more or less settings: 7.2, 2 thousandths or 2 10 thousandths. I've forgotten which decimal point that is, and a D of 2.4. And the errors I was getting was less than half of a degree. So there would be one there that would be 1 degree. At 0.1 is obviously a tenth of a degree. And the reason that steer effort is 0 is because I did go back to having a tolerance, because when I had that at 0, the motor would just like bang back and forth trying to get to that last little error. And I set the tolerance at, where's tolerance? At the moment, it's 4/10ths of a degree. So if it's within 4/10ths of a degree, then it'll come down here and get to 0. The other thing you had mentioned is set the steer effort to 0 if you're outside of a limit. I did that, although I have popped the circuit breaker or circuit fuse once. um, yeah, that was unrelated to the potentiometer getting outside of the angle. But anyway, that safety clamp is in there.
Uh, while you're right there on that screen, as I was saying to my comments, you should take, say that first two lines at line 155, 156, cut that out of there and plop it into the down below where you say, if error is greater than tolerance or error is less than tolerance, one of those is going right and one's going left. So take that check and stick it inside of one of those two blocks. Because if you don't do that right now, if you go all the way to the left and you exceed that number, it sets the effort to 0, and you can't move anymore beyond that, because it says, "Oh, I'm beyond. I'm not going to let you go either direction." So you can't recover from that the way it's set right there. But if you take those two lines of code and stick them into the block down below for whichever it's right or left, and so, the very last thing you do, you check that and see if it's out of range. If so, then set it to error just before you output that as a PWM. That says only if you're trying to go left and you're beyond the limit, it won't let you go any farther left. But if you say go back to the right, then it'll let you back out and everybody will be happy. So just as I say, just take those lines of code and merge them into those blocks down here.
Okay, that's good advice.
So also while you're right there, I see you're comparing against error. And error, keep in mind, error, that's an internal number inside of your PID function. And it's really not meant to be used out in the real world. So what you want to do is when you convert your PID and you return, I think you call it output, well, you want to use output instead of error.
You want to use output instead of error.
When you call the PID function, I think it says output equals do the PID. So output is the output of the PID, and that's what's going to control the motor. They're going to treat that as a power value. So if power value is 0, you don't want to do anything. But if power value wants to go in a positive direction, then do everything you're doing here. It's just that instead of using error as the variable, you want to use output as the variable.
You know what? I don't even actually calculate out, do I?
I don't know.
Yeah, I need to return error.
Yeah, there it is. 4 lines up. It says float out equals KP error.
Oh,
So you are setting it. It shouldn't do anything. You're not setting it. That just wouldn't have worked at all. So internally, you're returning it as out, and then when you call it the function, you say output equals the function. So out in the real world, it's called output.
oh my gosh, I'm going to have to go re you're right. I'm not flipping using fascinating. I'm surprised this damn thing worked at all.
But you're not using what you're setting out to the sum of those, and you're returning out. So yeah, that's doing what it's supposed to, I believe.
It's calculating it, but I'm not using it. Well, I mapped it.
And my other point is you shouldn't map that. Don't map that to anything. That is, you take output and slam it into the motors. That's when you start mapping it, you're just adding more. You're working around the PID by doing that. So you just want to say output equals compute PID steering, and then say clamp it at plus or minus 255 so the function doesn't complain. And then you want to go in the thing, say if it's greater than 0, go one direction. If it's less than 0, go the other direction. So I'm not sure what all this other stuff is, and you have it here. It says if steer effort, blah blah blah.
That's a safety clamp. Because I believe that if the steering is off 45 degrees, I want to use the high power value to quickly steer the motor.
Well, if you rip all this mapping out, it will do that. It's just looking at saying, here's my current position, here's the position you want me to go to. You multiply that by a gain factor, and you can crank that gain up to you can be off by a few degrees, and it'll slam the motor to full power. That's just the way it's intended to work. So you're trying to map it to something else here because I'm not sure why you were trying to do this.
Well, because I wanted a value between 0 and 255 for steer effort. In yours, how do you vary? When do you vary your steer effort between 0 and 255?
That's what the output of PID does. That's going to give you a number between 0 and some large number. And then when it falls down, you clip that to 255, so you can't put out any more than that. And then that's just what you use. That's what you put into the
But
control
the
thing.
input to my PID um, is the actual steering angle, not the power setting for the motor.
You will not control power setting. The PID says, oh, I'm off this far, slam this power in the motor, and it's controlling that. So right there on that line where it says output equals compute PID, output is what you're going to use as your power value.
Output is what I'm going to use as the power value.
Yes. So the output from the PID is a correction factor. It says, oh, I got to go this way or this way to get to where I need to be. And it generates that number, and that number results from your proportional gain, your integral gain, and your derivative gain. So it basically you put in two numbers, in your case, put in two angles, whether they're real angles or A to D counts. It compares the difference between those, and whatever, which is you're setting error equal to that, and then you multiply that by gain factors, and then you say, okay, here's the result, and you output that as here you're returning it as out, and then when you did the function, you're setting it to output, the variable output, and that's the amount of power you want to send to the motor to make the motor go in whichever direction it has to set the error to zero. So it's going to try to drive the error down to zero.
What's unclear to me is this is going to be an angle and this is going to be an angle. So that error is going to be a delta between two angles.
That's correct.
And you're still convinced that that should be regarded as a value between 0 and 255. You want to send that number to a Citron motor controller, which is expecting a number between 0 and 255.
Yes, that's what I'm saying. Except that error, except out coming out of that is not going to be limited plus minus 255. It might go up to 10,000, plus minus 10,000, which is why you want to clip it or clamp it to 255, because the PWM routine probably doesn't want anything higher than that.
Okay. I'll give that a go.
And you might want to look at those other, you had several examples of somebody doing PID stuff, see what they're doing, because they're going to call the PID function and then do something with that. And I'm assuming if you look at those, they're going to just take that number. You want to limit it to, in your case, you want to limit it to plus minus 255, because that's what the PWM, it won't take anything more than that. And then down below, where you're saying if error is greater than 0, that should say if output is greater than 0. That tells you which direction you want to go. And then if you scroll to that thing where you're doing the PWM and the thing that said if error is greater than 0. Let's see what code you got in there. Okay, yeah, right there. So it says, so right now you were saying if error is greater than tolerance, and normally you could put a 0 in there. 0 means you don't want any movement. I'll get back to that in a second about the difference between tolerance and 0. So, but that line of code is going to say if error is greater than tolerance, that means you either have to go right or go left. And I'm not sure. I didn't want to make statements because everybody's machine is going to be different to me, where you mount it, how you mounted your pot, and what voltage is on the pot, and various other things. So one of these two blocks is going to be going left, and one's going to be going right. Okay, it does say steer right. So that if that block is for steer right, then go up above there, and I assume that second on line 158 and 159, where it says if the steering angle pot is less than right limit pot. So put those lines down in just before you do the. It doesn't matter what you set your direction to, because you're going to set the power to 0. So right after that line you got highlighted, just stick that line 158 and 159 in there, and that will it'll stop it before it goes too far, but it'll let you back out. And otherwise, you're just taking that number, you're taking output and using that as a PWM to run the motor, and you don't have to go remap it to any other angles or or other ranges or anything. It's just that you run your PID values up and down, it's going to control how big that number is going to be coming out of there. And
And
it make a lot more sense if you're actually, trying to run it and you can see what's coming out of it.
and would you agree that if the difference between the set point or the target angle and the actual angle is 45 degrees, we want to, I say 255, but I've since backed off to that and set a limit. But
No, I would say if the error is 1 degree or 5 degrees, you probably want to put out full power to the motor. And that's just the way this PID stuff works. So you're confused on thinking you want to go back and put angle into there somewhere, but no, you don't care. Once you say here's the difference between my two angles, then forget about angles after that. It just comes out and says, okay, the difference is 3 degrees. So now you take that 3 degrees and multiply it by a proportional number, and now it's going to be a number like 300 or something. And then you want to feed that to the motor, so it's going to give you a lot of power to move over your 3 degrees until it hits zero again, and then it'll stop.
and if you were only 1 degree off, would you still want to give the motor full power?
Well, again, it's going to give it whatever power that proportional gain is telling it to do. So if you back your proportional gain off, no, it's probably not going to give it full power to do that. It's just that the further off you get from the set point, it's going to give it more and more power until it saturates. So you can, by controlling your proportional gain, you can either make that, if you're off by 3 degrees or off by 10 degrees or off by 20 degrees, then it'll reach full power and the motor will saturate. And then as you get closer, then the power just automatically backs off as you get closer to your set point. Or as the error gets closer to zero, you're putting out less power to the motor.
I mean, and these comments are probably not exactly accurate, but they're directionally accurate. That if it was off 1 degree, it would generate a steer effort of, -5. I think I have a voltage thing up here somewhere. Wrote down my voltage at different. Yeah, maybe I stripped that out. So as you might guess, 255 was 12 volts, and I don't know, this might be 4 volts.
So yes, you could do that, but that's not the way it's supposed to work.
That's not the way it's supposed to work. Meaning, if you're only off 1 degree, it's not supposed to get less power.
No, I'm saying you shouldn't run your PID and then throw that away completely and put your own algorithm in on top of that. I'm saying take
Yeah, I don't.
output, and that's your value to send to the motor instead of trying to do any remapping on that.
Okay. I will.
So back up one step here. You were saying that you've got tolerance in there because of jitters, and I know looking at your code, you are averaging the values from your steering pot, but the values coming from your target pot, you're not averaging those. Is it because the steering pot is that much more noisy that you have to average it, or you just didn't realize you averaged one and not the other? And based on that, if you take the values, you just say just write a little thing that, or take this code and say where you read the target pot and put it out on the screen, and read the steering pot and put it on the screen, and with that running, just say plot that on your like the Arduino serial plotter or whatever, and say how noisy are those if you're not doing anything. It could be once the motor starts up, then the steering pot becomes more noisy because you got longer wires on that. And anyway, that's where your jitter is going to come from, I think, is because you're reading your pots and you're not getting a stable, just a stable DC value out of that.
Yeah, remember. So yes, I knew that I was averaging the analog pot that is the actual steering value. I wasn't averaging this because, again, this is just a configuration program, and I'm expecting a steer angle target to come from the ROS navigation stack. Um, the I don't think I have a picture of the 10. You know what a 10 turn potentiometer looks like. That's what I've got on my tractor for actual angle at the moment.
You know what the value is that right hand? Is it 1K or 10K or 100K? Do you recall?
I don't. It's the it's the blue one.
Well, you can buy the blue one in lots of different values. But the reason I ask that is because if you have a high impedance A to D input, like say on the Arduinos that have the Atmel AVR, they have like a 1 mega ohm input impedance on them. So you can put just about any pot out there you want. You know, don't get it too large of value. But now when you switch over to the not the AVR, the ARM parts, their A to Ds work differently. And somewhere it says, well, they're an equivalent like 3K ohm input impedance. And that might, so you might just have an electrical issue there also besides just picking up noise from the motor. It could be that on the arm parts that it's the A to D doesn't work as well. So that's another reason to go back into your plotter and just with the thing sitting there not moving at all, look at the values coming out of your pots and say, are they just a flat single number? Or are they bouncing all over the place? And then I'm guessing once you start moving the motor, you're going to pick up more noise on it, probably at least on the steering pot because it's closer to the motor. And then you may see on your other pot you added on, just check as a basic thing to do. Just check to see how much noise is coming from those pots in the first place.
Yeah, I can do that.
Because
Um,
I think if you're adding that tolerance in there, I assume it's because one or both of those potentiometers is noisy, and it could even be like your Ki, Kp, and Kd pots are noisy also. So it could be you're just going to have to average all of those pots to get a decent value, but that's something to consider. First of all, just look at it and just look at the pots without any averaging, and of all 5 pots, say are any of them noisy without doing anything, and then I assume once the motor starts moving, the steering pot will become noisy, and then I assume that's why you originally had averaging stuck on that.
I originally had averaging stuck on there because the guy who wrote the example had averaging in his example. So that's where it came from. It didn't come from, hey, I'm getting a noisy potentiometer. It's because I think
And
this guy had,
And the reason people put averaging on that is because A to D converters can be, notoriously just be noisy trying to read whatever value you want, and that's why it was on there in the first place. And it could be that you may or may not need you probably will need that, but I don't know that just plotting it out to see what it's doing will give you an idea if your pots are noisy or not.
okay.
So another thing I noticed when your timers where you had one timer that says run the motor at 20 times a second or 50 times, I think it was like 20 milliseconds, and then you had another one that says print out the values at this time, and then you have one that says something about reading your pots or something. Let's see, which one is that?
And remember, this is just a configuration tool.
I realize that, but I think when I point this out, you're going to go, oh, of course. So one of those is for so you got parameter interval, steer interval, uh, the info. Is that the one that's printing stuff out?
Yes. And
Safety
blinking the
interval.
LED.
At at one point, I thought you had a timer that was running like every 5 seconds. You're going to read your target pot, or did you?
Yes.
What was I
The,
looking at?
that's right. Every,
Oh, that's considered parameters.
yes.
And you're doing it every 5 seconds. Well, what happens is when you do that, this thing's sitting there and everything's stable. You turn your pot, it's going to be a delay anywhere between 1 to 5 seconds before it even attempts to move. So if you would read that target pot at much faster rate or even at the same rate that you're doing the motor control, then as you turn the pot, you're getting it's going to try to follow you exactly. It's not going to wait 5 seconds before it attempts to start turning the thing. So just as a configuration or in real life, I think you'd be much happier. So as you turn the pod, it's going to try to follow you at the same time. Now, as far as the other values there, that KP, KI, and KD pots, uh, that's not really as critical. But again, once you turn them, you have to sit and wait there for 1 to 5 seconds, or between 0 to 5 seconds, until those actually get applied. So just all of those pots, probably if you'd read them faster, I think you'd be happier with that.
Yeah, I mean, I get your point. I was, I guess, being overly cautious and moving it slow to see how it was going to react because I didn't want to slam into something. But I get your point. Um,
And
the
based
thing,
based on that comment you just made there, I would say the first thing to do is go down the bottom where I said take those two lines and cut them out, stick them in the other routine down there. Do that first. So you got something that's limiting your travel, and then set that safety limit up to the point where you can only go a little bit on either side of your zero position. So, until you verify all that's working, don't set it out anywhere close to your hard stops. Move it in quite a way so you got a very small range you're playing with. You can go through and verify that all that's working. So you crank your pot back and forth, and it'll say it's right here in the center, and you set it over to here. Because say your hard stops are over here, you don't want to get anywhere near. So set your limit out about here. So as you crank your pot, then the thing is gonna go whir, and then the motor's just gonna stop when it gets there. And you back the pot off, and it should. Once you move those lines of code, it should. Let's see which one. This one. It should back off and control. So it'll control within these two limits that you're calling your safety limit, and your hard stops are way out here. So move it way in when you're first playing around and make sure you're nowhere near the hard stops as this is working, because yeah, it will surprise you very quickly, and it's better to not slam into stuff.
um, other things just to mention physically, this is what the underside of my board is looking like for power. Uh, what to point out, I've added a four 4 point relay deal there. Um, at the moment, that wire goes to the kill. I don't. I'm just going to say if this goes to ground, the motor stops. I don't know what physically that's. I don't want to call that a magneto. I don't know if that's actually a magneto. And then this relay is. I haven't. My intent is this is the power to the transmission servo. So because this servo, this is a picture of the servo mounted, because there's a neutral position and then this arm goes all the way back, which is full reverse. And I want to be able to make sure that that can't happen without, um, anyway, I'm going to control the power to the servo via the relay so that I can be reasonably assured that the microcontroller is up and running and sending a neutral signal to the transmission. So getting all these wires laid out, that's what the bottom looks like. This is what the top looks like at the moment. Microcontroller, which is the TTGO board, and the antenna for the LoRa, and signal wires coming over from the transmission servo, and this has a handle that goes into it, and that's the master power switch. The laptop will sit here. Again, that's the servo. Got to get those wires protected. I had a teensy inside of that, and I've taken that out, and so this is going to be controlled by the microcontroller on the board, and then that's simply a close up of the 4 point relay. So that's where I'm at. Sorry to blather on. Why are you smiling? What did I do wrong?
Uh, just, just the way you sum that whole thing up. That yeah, I say
What?
so just to sum up before we're done talking about that. So so were you going to go try to just take output and use that directly instead of doing your remapping? Or are you still going to insist that you have to remap it for some reason?
No, I think you've pointed out that if I can use the PID and feed it to, if I can, if the, if set point and input are both angles, and I can use that output and adjust these PID settings and feed that directly into the, um, a device that's expecting a 0 to 255 and adjust those gains, that's great. Then I can simplify the code and it's um, magic to me, but
But
that's what I'll do.
it is a fair amount of magic to it, but I believe that's the way that works. Now to your point right here, you said, well, you'll put the angles in and play with this. So I'd say set all three of your parameter pots down to zero, and then
Right.
move your thing somewhat off from zero position, and then just start turning your KP up until it's you're gonna as soon as you turn it, the motor is going to start whining, but it's not going to move. You turn it up a little more and a little more, and the thing's going to start moving, and it should get over and come to that point and stop. And then you can say, okay, now set the position back to zero, and it should, with everything set there, it should, slowly attempt to work its way back to zero. And if you don't have enough proportional gain, it's not going to make it all the way to the target that you set. But that's a good way to start off and get it so it slowly moves back and forth. And then you start turning your proportional up, it'll get the point, it'll go all the way to your target. If you get set too high, it's going to go to the target, it's going to overshoot, it's going to go too far and bounce back and forth. So that's just something you can play with at that point.
It's going to be fascinating to see what those numbers come out to be.
And then the other thing is, I would say, yes, take output, and that's where you're going to control your motor with. And then where you're checking against, you say error is greater than zero or less than zero. That should say output greater than or equals zero at that point. So I think that,
Yeah,
so
I'm going to delete this.
well, let's see, you still want to set the, once you get output, you still want to say if output, let's see, if output less than zero.
Yeah, I'm not going to use that.
Yeah, so somewhere that you had a thing you were clipping it or clamping it to 255. You still want to leave that in there. So, but yeah, that thing you're mapping right there, take that out, and it says if stair error, blah blah blah, clamp. So
Yeah,
so
this
the
is
next
going to
two
be,
lines, I don't know what those are doing either,
well, this was the clamp if it was over 255
but they don't say 255.
because I reduced the maximum power limit to even lower than 255 just to be safe.
Okay, so yeah, I would throw that out too. And just so down, like say line 161, that's where you just simply want to say if output is greater than 255, set it to 255. If output is less than minus 255, set it to minus 255. So that right there, just before you start outputting stuff to the motor, at that point, just blatantly set it to no more than plus or minus 255. And it has nothing to do with limits or power limits or angles or anything else. You just want to say don't let the output go higher than plus or minus 255 at say like around line 161. You could do that.
Right. So this is going to become output,
Yes.
and this is going to get embedded into these.
Yes, that's what I would do.
Yeah, I'm cool with that.
When you said that LEDC was acting funny, what was it doing? It wouldn't always work, or was it jittery, or what was it doing?
It it stopped producing a signal that the Citron motor controller would recognize. So the Citron motor controller neither the A channel or the B channel would turn on.
Do you know what kind of numbers it was putting out when it was doing that, or it just you just saw that it wasn't physically working? Because
Uh,
it could be you're putting too high a number into that ledc function, or it could be that it may just have a problem too. I had never seen that before, and when I searched for it, it sounded like they wrote that up for the ESP32. But I did some more searching. I think somebody found says here's Arduino code to also do that ledc function. So it's just a different way to do that.
yeah, so the steer effort value would have been a number, say 50. It definitely should have been moving the motor, but the motor wasn't generating, the motor controller was not putting any power to, the A or B channel because I connected up a voltmeter and it was like 0 volts.
Okay.
And
And back to your point, yes, you can use the analog right. That'll work. Yep, that's proven, and everybody knows that works. So yes, you probably at this point you're better off just using that, even though it's noisy. And then once you get everything working right, then you can switch over to a different driver function to do that.
and again, it's just a crazy hypothesis on my part, but if this was running as fast as it could,
Well, that's actually that's running slow. That's going to be it's going to have to roll over to like 65,536. So that's 65 seconds for each time it calls it. So that I don't think that's affecting anything.
oh, okay. Well, um,
So it sounds like you got some more to play with now.
yeah, I gotta here. I thought I had my PID settings and I don't.
And
Yes,
there
I definitely have
and
more
there's
to
no
play with.
sense to tune it to something that's not going to work. So, try to get the fundamental thing to get it to move back and forth before you start playing with the PID settings. So, which I think you thought you had that to start with, but I don't think that's what you wanted.
Yeah, the sort of bizarre thing is that it would actually steer, and I was happy with the smoothness of the steering. But we'll give it another go.
Okay, well, maybe we beat that to death now. So
I think we've
beat it to death again, and even though we've changed everything.
if I were a better PID controller programmer, we wouldn't have had to spend that amount of time on it. But I'm not, and so thank goodness you are. I'm done.
Okay, so I keep whining about trying to make new drives or new steering systems, and I said I bought this. Let me do this. Well, can you mute your microphone so this doesn't keep switching back and forth? Okay, so I went to the hardware store and bought this block of plastic, and I was going to try to use this to do my steering. I kept saying, well, if I just put a bolt in the end here and put my wheel on there, then this whole thing can turn back and forth around some imaginary pivot point. When I was looking, I found that here's a piece of oak board that I bought at probably Home Depot or somewhere, and it said it was 1 inch by 1.5 inch by 1.5 inch by 3 feet long. And you can see I already cut off that much of it. And I just found this out in my garage. I was cleaning stuff out. So anyway, you've got this thing is a nice, exactly 1.5 inch square. So I thought, well, I'll just use that as a reference. So I took my come on. So I took my piece of plastic, put it on the table saw, and measured down 1.5 inches this way, and cut that off. And it turns out that once I do that, I don't have enough room, so I had to take 2 blocks and cut off 2 of them to get the right length. But that's a manufacturing issue there. So after I cut it off, I got a block that looks like this. That's 1.5 inches up and down this way, and then I think it was originally 1 inch across this way. Here, can I turn this without giving things away here? I think it's 1 inch this way, and just arbitrarily, I don't know, it's that 2 inches, maybe 2 inches long this way. So what I did was I took that and then drilled and tapped a hole in the end of this. And it turned out that worked really well. This, I don't know what kind of plastic this is. It's not plexiglass, so it's not a hard plastic. It's a slightly soft. It might be what they call high density polyethylene or something. But anyway, so I drilled and tapped that for a 7/16 inch bolt, and that does screw in there. And then my thought was I'd have it pivot around like this. So what I did was I drilled down through here, and I drilled down through and put bearings on both sides. And these bearings happen to be, they're actually metric bearings. So the center hole is 8 millimeters, and the outside was something like 20 millimeters or something. But it turns out a 5/8 inch drill bit works just perfectly to do that. So I just ran a 5/8 inch drill bit down through it and then press the two bearings into it. So now if I have a bolt here, calm down. So this thing can swing back and forth like this. And in fact, here's one that's all put together. So it's got the wheel on there, and I should get a slightly shorter bolt and maybe get a rounded head with a like a Allen screw, Allen wrench in the end of it, just so it's not sticking out that far. So basically, see the thing that can pivot around this point like this and steer. So that's what I played with on that. And so theoretically, if I put then two of those, two of them side by side like this on an axle and get them so they turn, that I should be able to build just a smaller version of the front end that I have right now on my mini tractor. The other thing is, if you do this, see I've got that bolt screwed in there and then the wheel is on there, it's gonna want to tend to try to unscrew that as it drives around. So I might have to put Loctite on the threads or put some super glue on the threads, run it almost all the way and put some super glue on and crank it down. And then the other thing was, let's see, super glue, blah, blah. Why was I saying that? I forgot why I was saying that. So anyway, if I put it together, and then that should be, I'll have bearings, actual ball bearings against this shaft. And these are ball bearings here. And then I just have to build, like a bracket that goes here with a bolt that comes down through for it to pivot on there. And I think to do that, I can just take two pieces of steel angle and cut them off, about whatever the width it is, cut them about that wide, and just lay two of them back to back. So there'd be a seam right here. And just take the welder and weld those two together to make a C bracket like that. So that's just some things I was thinking about on that. I was also saying I could probably scale this up and down, and if I just use a smaller block of plastic and use something smaller, like say rollerblade wheels or the scooter wheels that are built like the rollerblade wheels, I could just go to something smaller. And this is the bearing that's in the block right now. It's got 8 millimeter hole in it. And here's some others I found in my box, and they're built exactly the same way with a flange on it. And these happen to be 1/2 inch outside diameter and 1/4 inch inside diameter. So basically, it's just a smaller version of that. So if I get a smaller block of plastic, smaller bearings, and then the smaller wheels would probably have, say, a smaller hole here, but it's just a matter of figuring out what bolt fits through and then drill and tap this hole for whatever that is. So see, I can make a smaller version of this, or then I had the other pieces, which I didn't bring down, but they were, I got a block of plastic that's the same dimensions as this wood here. This happens to be oak. So I think if I drill and tap it, that might work. I was looking on the internet, people were saying, yeah, you can drill and tap wood and it will work, but they were saying, use something like hickory, or I can't believe the other woods were, but essentially, I think I can make it work. And the reason for even considering the wood is you can go out and buy this off the shelf. It's a real product. You can just walk in and buy it. I was thinking, well, people aren't going to be able to find that plastic that I have, so that might be one reason to consider that. But anyway, this is big enough dimensions that I could drill a big enough hole and put a 5/8 inch bolt through here, and put on like the $4 pneumatic tires that I've got on my mini tractor, and basically so just build a bigger version of, scale it up that way. So again, I put bearings in right here somewhere, and I'd probably go ahead and use those ones at the 8 millimeter hole, or I've got some bigger ones that maybe have a 1/2 inch hole that I could do it. So that would be like 3 different sizes I could build just by picking and choosing different parts and piecing it together. So let's see, anything else I wanted to say on that? Oh, so that, I think if I just build an axle for that, I can build it just a miniature version where I already have. And then I thought, well, if I wanted to test this, because what I really want to do is test the two DC motors in the back instead of having a mechanical differential. So I've got this thing. This is one of my old robots. And this happens to be, it's just a piece of round plywood. And then it's got caster wheels on the front and the back. And then it's got a shaft across the middle. This is just a piece of 1/2 inch rod from the hardware store. And then I've got some aluminum brackets that I made. And then the motor itself. So it's a gear motor. It's a Pitman motor. It's got an encoder on the back. It's got a gearbox here. I think it's a 65-to-1. And then right here, there's a pulley screwed onto the motor there. And then over here, there's a pulley bolted onto the wheel. So as I turn this, I have to lay it on right now. So it turns like that. Now, these are small enough motors. They're going to be like an RC car. They whine when it drives around, but as long as you don't drive too fast, they don't whine as much as an RC car does. So anyway, I could take this off, just unbolt this. And if I want to, I could cut this shaft off so it's smaller. So at some point, I have to decide how wide do I want this new thing to be, and that's going to set how far apart I put the front wheels. And then by controlling the length of the shaft here, I can decide how far apart do I want the back wheel here and this back wheel here. So it's just a matter of, I could use that, or I got a couple more old differential drive robots laying around that I could just use them directly. The other thing is, without modifying this at all, I could, just to prove this out, take these two caster wheels off and just run a frame that sticks out the front and put my axle for my Ackerman out here. Or I could just put like a tricycle, so just put a single wheel that's steerable. Because all I want to do is prove that having the two DC motors and the encoders on them that I get, number one, it will drive around, and number two, I will still get valid odometry by simply running these two motors in parallel or running them in series. I'm thinking they should equal out, and everybody should be happy on that. So I could do that, or my other two differential drive robots. Again, if I just take off the caster wheel, extend the frame out, and put some kind of steering on it, whether it be a tricycle steering or an Ackerman steering. So I've got different things I could try. It's just a matter of one of these days I'll have to decide: do I have the ambition to do this, and do I want to waste enough time to go down that path? So that's kind of where that project is. I'm doing that in between other things, and yeah, when I'm not watching TV, when I'm not trying to clean my garage out, I think about this kind of stuff I'm showing you right here. I don't think I've done anything else with my mini tractor other than it just sits around in the way. And again, the whole point, I was looking at this new thing instead of just blatantly wasting time. I'm still thinking that my mini tractor is too heavy. Too heavy to pick up and throw in the back of my car. It's slightly bigger than I'd prefer, again, for transporting and moving through doorways or whatever. So I was thinking I could make one about 3/4 the size of my existing mini tractor. And the biggest problem making it smaller is now you don't have as much room to put sensors on it. But as long as I use, say, if I use a LiDAR, this is the I think is the XV11 this is the original vacuum cleaner LiDAR that they came out with. So that one, and in this case, is plugged directly into a guy in the Dallas robot group made this little board right here that's got a Teensy 2.0 on it, and it connects to the motor, and it controls the speed of this. It's just got a MOSFET and a PWM to control the speed, and then it's got a serial line that comes back probably right here, and then it's just got a USB connector on it. So it's just got this is all backwards. Let me do it this way. So it's got a cable that comes out of that little board here. It's USB and plugs right into a Raspberry Pi USB. So it gets the power and the communication right off that Raspberry Pi. So I could put that kind of stuff directly onto this because this thing isn't very big. This is what 8 inches in diameter, and it's got a full ROS computer on it. It's got a LiDAR on it. It's got DC gear motors on the bottom with encoders, and then it's got this cute caster wheel. It's one of those Omni wheel things, so you don't have this thing. A regular caster wheel swings around like this and causes problems if you don't have an Omni wheel. It takes up no more room than what you see right there. But this only works on like a smooth, flat floor. So anyway, my point was, as you make the thing smaller, then you have to find sensors and computers to put on it. But as long as I'm willing to run a Raspberry Pi on it and run this kind of LiDAR, and then I could either put like the Microsoft Kinect sensor or what's the Asus one that was called the Action Pro Live, which is smaller. Again, it's smaller than the Kinect sensor. So there's various things you can bolt on. It's just a matter of, it's a trade-off between, you want it small enough that it's cute and easy to maneuver, but you want it big enough that you can put on, whatever kind of computers and sensors you want to use. So if I make it smaller, I probably don't have enough room for a laptop anymore. So I'd probably have to go to either a Raspberry Pi or like a Jetson Nano or something like that. So I think that's all I have to babble about on that today. You're on mute.
Is the name of your larger tractor Sammy?
Yes, it is. But
And so
technically, it's Sammy too, because there's a previous one to that that's even bigger that I gave up on. So this new one might become Sammy 3 if I actually build it into a complete thing to play with.
I know we were simulating Sammy earlier. Did you ever try to run Sammy in the physical world on with the ROS navigation?
I have never actually fired up ROS navigation on that, but it's got all the pieces there, and it's just basically due to my laziness that I haven't done that, because that also has that big expensive sick lidar on the thing, and it's got all the pieces in between to work. It's just the matter. I just have to say load the navigation stack on the laptop computer and basically tell it to go. And theoretically, it's got all the precision GPS, and it's got the lidar, it's got the encoders on the wheels, so it has everything there it needs. It's just a matter of actually trying to do it sometime.
What are you going to name your next one?
It'd probably be Sammy 3.
I was thinking those two caster wheels are probably in perfect alignment. You could just bolt another piece of oak straight out and hang your axle off of that.
Well, there's a bunch of things I could try, and it's just a matter of, when you go to do it, you say, what do I have for parts? And I say, what do I have for scrap wood? Well, if I take my camera out, it's all leaned up against the outside of my garage right now, where I've got metal and plywood and pine boards and plastic and everything lined up. As I'm cleaning stuff out, I was lining up everything out there. And I could have taken a picture of all the crap on my front sidewalk. I've got this huge, about a ton worth of stuff that I've got to take out and take the recycling place. I got big boxes of printed circuit boards that I've collected, and old equipment, and a couple of oscilloscopes. And so that's been on my sidewalk for about a week now. I'm surprised nobody's complaining about it.
Do the oscilloscopes work?
Maybe, but they're all really old stuff. That's not. One of them is an oscilloscope mainframe. It's made by HP, and it's probably this wide and about this tall. It's one of those things you're supposed to plug in modules into it to do the actual, the sensors or whatever. And I've got one that's a Tektronix, like a 485, which is, that's 50 years old or whatever. And I'm probably just going to take it all to the electronics recycling place and say, do whatever you want with it, just get rid of it. But no, I don't have any modern oscilloscopes. I've got the one that I bought that's a real nice, all computerized. It runs like a 1 gig sample per second with 2 channels. I can even plug it in the computer if I want to get plots on my screen. But so there's a major jump there between all the really old crap that is questionable, and then I got this new one that I bought that is what I normally use for an oscilloscope.
Cool. I think we can stop recording.
Okay.